Okay. All right, well, everyone, thanks for showing up here. I would wave as a greeting, but as you'll see, I'm actually driving the presentation with an Xbox 360 Kinect as my user input device, and I'll show you a little bit of how that works here. Just a show of hands here, who has ever seen a demonstration of where an Xbox has been used for a human interface device? Okay, a couple folks. All right, so for those of you who've seen it, that'll be kind of old hat. Just one of the disclaimers I wanted to go over. This isn't terribly groundbreaking using this for that, but I'll get into why I think that it's something different. The stuff I'm about to talk about, though, has nothing to do with my day job. I'm a pen tester. This isn't pen testing, so cut me some slack, please. Yeah, not that kind of pen test, Neely. Most of the time the pens work. The quality control is pretty good. It's really an issue of getting the paper and ink flow quite right for consistent testing. I was paying attention last year. Yeah, I really will. Come on. There we go. This presentation was done with my own equipment and on my own time. So we're not dealing with pro-grade stuff. And it's actually very affordable, so it's something you could do. And I've written none of the software that I'm using. And the purpose of this talk is more to be a concept car, something to think about, something to excite your imagination. And we're not going to be talking about big data in the classic sense. A lot of people think that unless you're talking about terabytes or petabytes, that you're not dealing with big data. And for me, I think that that's kind of silly, because if you have too much data, stuff that you can't interact with, that you can't do meaningful analysis on and act on, you've got big data. And that might be in the gigabytes or megabytes region. It's more data than you can use, and you wind up drowning. And this analogy holds up pretty well, because as tragic or funny, depending on your point of view, as it is, you can drown in only a couple inches of water. Same thing with data. If you have too much, no matter how big it fills on the disk, you've got too much. Now, that's not to say that traditional large data is something to sneeze at. There's a workshop later on today at noon called Thinking Big, Analyzing Big Data, and that's by Daniel Washburn, and he's going to be showing some cool technology and techniques that you can use right now today to handle very, very large data sets. Now, as you're plainly aware, I'm doing this is an entire presentation and demo, and the way what I'm doing for this is I'm using a tool called Kinect Gesture. And I'll show you the interface right now. This, what you'll see in this top frame is what the Kinect cameras see. And then in the bottom frame here, you'll see a clipping, and that's what's in range of the laser viewfinder. Now, calibration on this right now is pretty raw. This is alpha, maybe even pre-alpha quality software, but it's pretty neat. You can see here it's tracking my hand, and you can do some neat things like change the settings in terms of the angle that the Kinect sensor bar will be aimed at. You have a 30-degree arc of motion. Now, those of you who are in the back really won't notice this motion, but those up close can vouch that it's moving up, and then we can move it all the way back down. This is an open framework. It's the stuff that I'm using is a component of the Xcode developer base for Mac developers. You can get this stuff free of charge from Apple developers, from the Apple dev site. Fair warning, they do charge for some of the Xcode packages. And so you have to kind of hunt around to find the free developer version. And certainly setting up the free developer version is a lot more tedious than setting up the, say, enterprise one, which is just a normal app install process. They've removed a lot of the easy-to-use stuff just to make you want to pay. But if you set aside, like, I don't know, an hour or two, you'll be able to get it up and rocking. And you can install different framework components. And this is the kinect gesture one. There's other ones that have finer grain tools. There's one that's called kinect gesture fingers, where instead of sensing the hand like this, it would actually be able to detect each individual finger. And so in theory, like, I could like make, you know, like gang sign type things and have different events happen. The only problem is that code is even more alpha than this. And as you can see already, I'm struggling. So I cut my losses and went with something that kind of sort of worked versus something that had a little more whiz-bang features and didn't. So any questions on the kinect gesture stuff so far? No? Okay. Let me pause that. Oh, geez. Okay, first presentation, let's go. Yeah, fire away.
Does the stuff that comes into the built that actually does include the voice stuff? And does it do anything with voice input or
Yes, there are voice input modules. There's a community, several communities that do stuff for the Kinect sensor bar mods, and there's ones that do voice recognition. And one of the more advanced ones that's interesting is they use VXML, voice XML, that allows you to create your own library of commands. The thing that's interesting, and I understand now why on the Xbox, when they have the voice commands, if you do the voice navigation, it's very limited. The reason is that it's pretty janky, even under the best of conditions. So what I've noticed is on the Microsoft Xbox, when you log into Live and you've got your media console mode, that menu, all of the verbs that it will accept are very, very different sounding. And the reason why is because it's like when it tries to do like speech to text, like it's nothing like Dragon Natural Speaking. It's very primitive. Great question, though. Okay, so we're going to give this a try. We'll see how it goes. There was a book that I read that was very interesting. And it was called Data Smog. It's by David Shank, and it's a very interesting read. In it, he poses a couple interesting conundrums and problems that he thinks we're going to be having in our modern world. And one of the things that you got to know about this book, though, was that it was written in 1998. So if you think about it, somebody talking about data smog in 1998, this is before Twitter, before Facebook, before so many different things that we just take for granted. So for somebody to talk about, oh no, we're going to have too much data that we can't act on, seems kind of ludicrous. Case in point, this was our best bet for mass storage and removal of drives. And for those of you who don't know, the Jazz drive was pretty horrid. But David Shank, the author, did have a couple things right. One of the things that he said is storage density is not going to be a limiting factor. And by and large, that's true. Now, if you know somebody or you yourself or someone you love is developing data density solutions or works for hard drive research, that's important stuff. And I'm not saying, boo-hoo, your work is unimportant. But what I'm saying is that's not yet been our bottleneck. We just build more and more SAN racks. And then eventually somebody comes up with a higher density drive and we replace the drive units, and presto chango, we're good to go. So that's not been the big issue. Another item is that data access speed. A lot of people at the time that he was writing that book was saying that we would have, potentially terabytes of data, and that it would take forever to access it. And if you think about it, when the Jazz drive was out, those were really freaking slow. So it seemed like a fair problem. And he said, no, that's not really going to be the issue. And with the wide adoption of RAID 10 or 1.0 and 5.0 or 50, he's been proven right again. His main contention was that getting meaning out of the data, being able to do something, being able to digest it, that was going to be the problem. And he's right. One of the things that I find interesting is where I work, there's certain things that, elevate people very quickly in the corporate world. And for those of you who are not, in the corporate world, you might think, brown nosing and that sort of stuff is the way to get ahead. And it might help, I don't know. Depends on who your management team is, I suppose. But the thing that I find most interesting is that people who can parse numbers, who can speak to numbers and make them be understandable and digestible to people who are not as numerically literate as they are, advance very quickly. As a case in point, sometime, just as an interesting exercise on your own, look up what the average salary is for an actuary. They make bank because that's what they do. It's not that they're computers. They're not taking anything magical. They're not doing any new formulas. They might be, but the thing that they do is they make it meaningful. They bring context to an ocean of data. So you might be saying to yourself, well, Mick, you're a security guy. Why do you care about this big data thing? Big whoop-de-doo. Well, here's some sobering numbers. Last year, Verizon Data Breach Report said that for the breaches that they covered, 86% of them in their logs had some indicator that an attack was about to happen, that they were either being probed, that they were either being footprinted, or some precursor of an attack, or even the early stages of the attack themselves. It's very often that you'll see an attacker, say, try a denial of service attack, and they might get the port wrong, or be trying to do a web, attack and have put your DNS servers in that range. So there's always some kind of, in 86% of the case, there were indicators. Guess how many times that was found for last year? 0%. We suck. What about SIM? Now, the interesting thing that they said when I asked them about that, because it was just a couple days ago that I was talking with a guy who worked from Verizon, and he said that in those cases, after they were notified of the breach, they looked at their SIM and said, oh yeah, here's the evidence. So they're using it more as a forensics engine, which, that definitely helps. I mean, doing forensics and containment is, I do not want to in any way slight that task. It is brutally hard. It's like trying to find a needle in a stack of needles. But the problem is, they had the stuff, they weren't acting on it because nobody was putting it into context. And I would say that we're this bad. Now, one of the things that after I learned this, I was like, man, there's got to be somebody out there that's doing a good job routinely of bringing data and making it meaningful. And I had to look hard. I really did. And then one day, it just popped up to me. For my job, I travel a lot, and I opened up my hotel room, and there was the answer. The USA Today. The USA Today, on almost every day of the week, at the bottom lower left corner of the front page, has an infographic. The infographics are cutesy. The graphs might be, like sharpened pencils or half-eaten hot dogs to indicate, food consumption or whatever. And statisticians hate the USA Today infographic because it doesn't give, proper correlation, and, you can really fudge the numbers with it. But it's very approachable and digestible. Now, it's honestly my contention that the USA Today infographic is sacrificing clarity for simplicity. And certainly there's a whole continuum of where you need to find that. I don't know what your organization or your particular needs are for getting that clarity versus actionable data are, but these are somebody that's getting it right. And this has been an age-old problem. In the 70s, there was a book called How to Lie with Statistics, and it's now currently in its 17th or 18th run. It's a really cool book, and what it tells you are some of the common gimmicks and tricks that people do when they're dealing with large, data sets and how they can fudge things. Case in point, when you say what's the average, income in an area, there's which average, right? There's 3 different ways that you can determine average: the mean, median, and mode. And depending on how your outliers or how large your data set is, you can skew one way or the other. But all 3 are considered average. There's other ways that you can lie with statistics, and it's quite apropos that I follow up the USA Today graphic with this particular book, because USA Today graphic does this one all the time. If they show something as being, say, like, this is 200 times bigger than the other item, you would expect that they would just raise it 200 times, but they also make it wider too, so that it's actually 400 times larger, so that when you're looking at it, you say, wow, that's like really a lot, as opposed to just a lot. So just some interesting things. Now, there's a lot of research and development that's going on in statistics and analysis. Some people say that we're living in the golden age because there's a lot of new things that are coming into play. There's some very cool projects at the university level where people are using graphics cards to crunch through large data sets very, very rapidly. And that's pretty freaking cool. However, I would posit that we're living more in the early industrial age, where there's all these belts and whirly things exposed, and God help you if you're wearing loose clothes, because Lord only knows what body part you're going to lose in a second. And I think that this analogy bears out more because we continuously see data breach after data breach after data breach, and yet 80% of the time, 86% of the time, there's precursors. I would love to go to a casino where I had an 86% chance of winning a game of chance.
Well, the 86% number
Yeah.
is a misnomer. That's only in cases where one detected it.
Excellent point. So,
I'm not taking into account the fact that if someone detected it, stopped it, they're not going to make the right.
fair enough.
It's effective, scary number.
Yes.
And most people don't do it well. But
Right.
that's not necessarily saying.
Yeah. I mean, that's an excellent point. Just for those on the yeah, speaking of lying with statistics, for those on the watching the rebroadcast, the comment was that the 86% are only those who were actually compromised, and so in that case, that's playing around with the sample set, which is very much a big problem in statistics. So, can technology help get us out of this bind? I think that it can. It does have a place, and there's some really freaking cool technology that's coming out. Just about everybody on the Twitterverse was like, "Oh my gosh, Google Glasses! This is great." And I agree. This will offer a very new avenue, a totally new user interface. The paradigms that we've used in the past to work with data can shift, and it's up to us, the geeks, to determine what that is. That's really cool and exciting. And if you want to peek at what this future can bring, read these 2 books. They're awesome. They're real gripping, in my opinion. However, having spent my time on the internet and browsed through, say, 4chan/B, I can't wait for the hacks where you're seeing this. Nothing but this on your Google Glasses everywhere. So understand that it's not always going to be great. A big part of the problem that we have are our tools. Many of the tools that we're using simply aren't up to the task. And the tools that we have, we don't know how to use. I purposely picked golf clubs because I have a set of golf clubs. I am not a golfer. That becomes evident when you see me hacking. And it's not keyboard hacking, it's just chopping away. There have been times that the divot goes further than the ball. And that's the problem that we have in a lot of institutions and corporations. There are people who are just kind of winging it, hoping that their data analysis stuff works and works appropriately. Now, there's a very interesting tool. I've done a little bit of research on this, not as much as I'd like, but I found that those companies that are engaging in data analytics have invested significantly into it. And they are using a software package that has been around for well over a decade, and it's written by a very large, well-known software company. And every single year, this company just dumps millions into R&D and user case analysis. They want to make it better and better and better. And about every 2-3 years, there's a new product release of it. And I see some of you people like, ooh, what's this product? You're saying, shut up and take my money. What is it? It's Microsoft Excel. That's what we're using. Now, Microsoft Excel is great in doing simple sums and averages and that sort of work, but when you start talking about things like data correlation, log analysis, it breaks down. It breaks down quickly. Does anybody know how big of a data set you can put into Microsoft Excel? I'm sorry? Yeah, it's around 65,000 rows, which, I'm sorry? It's, yeah, that's, okay, good point. Right, it's not nearly enough to, so like, for case in point, if you have a moderately trafficked website and you put your, Apache HTTP log in there, it would just cack out, it simply is not up to the challenge. Yes. Now, there are some things, though, if you just visualize, the Excel workbook. What if we gave it truly unlimited data size? Just truly remove that barrier. And if we remove the stupid bars and the ribbons and all that crap, hey, it's a database all of a sudden. That's pretty neat. But what if we took it one step further, and instead of each worksheet, we stacked worksheets on top of each other? Instead of being a table, you're going to have something that looks a little bit like a cube. What that is called an OLAP. OLAP data cube. OLAP is for online analytical processing. Now, it doesn't have to be 3 dimensions like I just talked about. You can actually have OLAP data cubes that are what are considered hyperdimensional. You can add as many dimensions as you want. The problem with OLAP data cubes is that, how do I put it? Okay, think of how difficult it is to have a proper rational database with normalized data. Okay? Now add another axis, and add another axis, and add another axis. We have people that don't understand what an outer join and an inner join are. Imagine what you do when you add a Z-join, which is one of the one of the commands when you're dealing with OLAP data models. So, okay, so the question was, do you care that much about the relationality for the different components? Okay. So assuming that you just write it, dump it, and you just have this big blob, well, if you're in that scenario, I would contend that you're more dealing with an unstructured database table, like a NoSQL blob. The whole point for having a data cube, at least from the research that I've done, indicates that there needs to be a relationship between the different axes. So you might have, say you have a large server environment where people are doing a network sweep, and you want to see which servers, so you would have the number of servers and the time that they've been scanned, and then maybe the operating system, so that there's a relationship, and you can flip the data tables as needed to pull and show those relationships. One of the more interesting uses of a data cube was about 5 years ago, I believe, was by the Kroger company in Cincinnati. They were doing data mining on shopping records. And they were able to, by using data cube technology, they were able to see relationships that were not readily apparent. For instance, there's almost, not exactly, but there's almost a one-to-one correlation of if you are a man under 35 years of age and you buy diapers, you're going to buy beer. I don't know why that is. Maybe it's like, you know, hey, a little reward. Maybe it's like the kid's just crying, I can't take it anymore. I don't know, but they just found that. And so what was pretty interesting is they actually got into a little flack for doing this, but on the end cap at the beer aisle, they had diapers. And people were like, I don't know if you're really meaning to push that particular, yeah. Oh yeah, the Target incident where they knew that the girl was pregnant before the father did. Yeah, exactly. Is there? Okay, over there. Well, you know, that's a bigger issue. One of the problems that I have, and this is, I mean, this is me, Mick Douglas, speaking as a private citizen. Again, this is me, Mick Douglas, speaking as a private citizen. I think a huge problem that we have in the U.S. is that our laws regarding our personal privacy, our digital privacy, are completely FUBAR. If you look at the rights that the people have in the European Union, they blow ours away. It's really quite shocking. As a citizen of Great Britain, you can write any particular company and say, hey, give me your information that you have on me. They have to furnish it. They have to furnish it within, I believe, a week. And then you have the ability to say, no, 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 delete these things. You're not allowed to carry this information. And then they have to remove it from their stores or from their data stores. Can you imagine what would happen if you did that to an American corporation? They'd just be like, yeah, okay, good luck, buddy. Well, yeah, that is an excellent point that you brought up. For instance, like in London, you if you're inside the square mile of the official city of London, you physically cannot be off closed-circuit TV. That's pretty creepy. So, you know, there are pros and cons, and thanks for pointing that out. Well, yeah. Yeah, let me skip ahead here a second. So there's a couple places that I would recommend that you check out that are doing some pretty interesting things with data visualization. XKCD, it has some amazing data visualizations. The one that was probably the most impressive was the money one, and I see some nodding. And that for those of you who don't know what I'm talking about, hit Google, hit Bing, or whatever search engine you prefer, and type in XKCD money, and it's a large PDF with each little, he draws these little squares, and they indicate, I believe, millions of dollars. And then he makes these bigger bricks that show how much money has been spent on different things. And it's quite shocking to see how the money's been allocated. And it brings a certain reality to these very large numbers. Because part of the problem that we have is once you have 9 zeros, 12 zeros, 15 zeros after a number, your head just kind of goes, and you're like, oh, that's big. You know, and it's even I have a hard time understanding that a billion is 1,000 million. It's much bigger than a million. So just something to see. So now just go out there and try something. I'm going to show you some of the models, the software things that I'm going to be continuing to play with. Certainly this needs a lot of work, but there's some things that I'm modeling after, and I want to show you them right now. So one of the things that I mentioned about OLAP is that you can have it be hyperdimensional. And this is a big freaking problem when it comes to visualization. If it's a 3D cube, that's something that people can easily grasp and get. But if you're talking hyperdimensional data sets, that gets really freaking ugly. And this is a tool which will help you deal with hyperdimensional data sets. This is the OLAP cube. It's a Java, here, let me get the website up on here. That was written for a doctoral dissertation, and it lets you interact with the data sets, and you can change your axes, change your targets, and then, oh boy, I can't hit the refresh button because it's off somewhere where that window is now. But when you refresh, then you will see what the different data values are in that particular tuple. For those of you who don't know, tuples are the individual data components that are in the database. So that's a pretty interesting thing. One of the demos that I was working on that has horribly failed was a Flash component that worked something like this. The idea, and I'm going to give this a shot. I don't know if this will work. Oh, it's okay. It won't even go over to that screen. So, like I said, concept car, folks. The idea of this was if you had only a three-dimensional data cube, there would be a hot zone that you would click in, and you could rotate and play with the axes and see your data. And then from there, using the pinch to zoom type functionality, you would be able to zoom in to the data and then grab it, rotate it along. But as you can see, simple mouse controls are giving me fits. So I'm a couple months away from there, but I'm going to keep at it. It's very fun. Frustrating but fun. I highly recommend it. Yeah. Oh, that cube, that was a sample data set that I took my home lab, and I was doing a bunch of Nmap scans, Nessus scans, and Metasploit attacks, and I took them, and it was attacks, servers, and time, and then you would be able to drill in. The goal, ultimately, is to make kind of like a more readily understood SimSem kind of concept where you can say, okay, I saw a packet like this. Now, give me two things. Give me the timeline for all of these attacks and show me which hosts were attacked. And then, I'm sorry? No. Yeah. Mm-hmm. Okay, if you don't mind after the talk, I'd like to chat with you about that. That'd be cool. All right, well, that would definitely be very cool. So one of the points of this talk, though, that I want to definitely strike home is that just go out there and try something. This is a woefully understaffed area. If you think that you're not that good of a coder, if you think you're not that good of a statistician, it doesn't matter, because you're competing with no one. So literally, you can go out there and like make the most atrocious thing, and people will say, "Hey, that's better than we were before." And honestly, it's that sort of stepping stones that will help. Maybe you will improve it and say, "Hey, you know what? A couple months down the road, you'll say, "Hey, I can make this better because I've learned this." Or somebody else can look at it and say, "Oh, hey, this is kind of neat. Let me put a little spin and polish on it, and we got this." The problem is, I showed the golf clubs as the tools that we have. We don't even have metal, in my opinion. We're like bashing at that little ball with like hunks of twig. And it's really like, some people have better twigs than others, but when you consider how important data is and how much, money is on the line, it's shocking, just breathtakingly shocking how crude the tools are that we have. Now, as you can see, this talk was pretty flawed. The Kinect was not that cool. It certainly needs a little more tuning and better understanding of the space. And one of the things that I wanted to point out was a good story that I remember reading on thedailywtf.com. That's a site that was developed by a guy named Alex, based here in Cleveland. A real nice chap. If you ever see him, say hi. But the Complicator's Gloves is an interesting story. And this was posted years ago, but it really resonated with me, so I remembered it. And the story goes this way. This software developer is riding his bike into work. And he then goes onto the team message board, and he says, "Boy, it was kind of cold today, and my hands got cold as I rode into work, and that made me sad. Is there something that we're really smart, can't we come up with something that will fix that?" And after, a half day of, brainstorming and geeking around and playing with hardware components, they had a very, very rough prototype that they were going to start affixing to this bike. And it worked something like this. There was going to be a generator that spun off the front tire, and it would shoot the electrical impulses up to the handlebar grips. And the handlebar grips would warm up with the electric current because they would just be simple resistors. Hey, that's pretty neat. And they had some of the components assembled, and then someone came in and they said, "Hey, what are you doing?" And they were all excited, and they said, "Hey, this is really freaking good. This is awesome." And he goes, "Hey, idiots, that problem's been solved." And guess what? I did the Complicator's Gloves today. I'll admit it. Advancing slides in PowerPoint has been solved. There's little remote clickers. There's what I was doing when the thing finally failed, hitting the space bar and the cursor keys. So one cautionary tale that I want to give you is throw stuff on the wall, but if it doesn't stick, be willing to let it stay on the ground. There's no point in spending your time tilting at windmills. There's a lot of good work to be done, but if it isn't going to work, it's not going to work. To be honest, I'm really disappointed in how this performed. I'm going to be giving this talk in a couple weeks, a different version of this talk to a much more corporate audience in a couple of weeks. And if the Kinect fails again at this level, I'm probably going to just drop it, maybe for a year or so, and see if they can get some of the syncing issues handled. Or maybe it was my fault. I don't know. We'll find out. So a couple things to remember. You're always going to miss 100% of the shots that you don't take. That's from Wayne Gretzky. And then on the flip side, though, is perfection may look great in his shiny shoes, but he's kind of an asshole, and nobody invites him to their pool party. So don't be afraid to fail, folks. So get out there and develop stuff. Have fun. I'm going to be doing it, and I'll be posting what I do. Have fun. There's literally nothing, like next to nothing going on in this space. It's really like mind-boggling. Go out there and do something. Feel free to contact me. Any questions? Yeah, so one of the tools that I've tried playing around with and I've been having some really cool success with is an open source tool called Octopussy. And Octopussy is Perl engine that will do all the analysis, and the graphics, the charts that it makes are gorgeous. It's like data porn. The name is unfortunate. I've recommended it to a couple friends in different corporate environments, and I'm like, hey, what you need to get is Octopussy, and they're like, yeah, I can see that one going over really well. But it's a very cool tool. I'm a security guy, so I know I'm more comfortable with the security tools. OSIM, the open source SIM by Alien Vault, has some amazing stuff in it. And the thing that I really like about that, there's a couple disclaimers for that. One, to get the full version, you do need to pay some money. I don't get any kickbacks from them, but I'm a big fan of their work. But the thing that I really love about OSIM is that it's a holistic thing. Your Nagios data, your inventory control data, all of this stuff feeds into one repository, and there's a lot of good reports that are done on it. The problem with that tool, with OSIM, is that setting it up is not for the faint of heart. You're almost required to use the pre-built VM, because if you don't, you're in for potentially months of dependency hell. But even getting it set up in all the subcomponents is a significant task. So I'm not trying to say, no, don't go with it, but just I want you to have a realistic expectation of what you're getting into. But I do have an up and running OSIM instance, the free version, and for my lab, it's actually doing pretty interesting stuff. It's worth checking out. Other questions? All right. Well, I want to say a couple, use my remaining time to thank some folks that made this possible. The Kinect Gesture dev community is just an awesome place. If you saw this and thought that this was interesting, get out there. They've got an IRC, they've got forums, and they just love people getting interested in geeking out in this. The Apple Xcode project, very, very cool. Can't overstate how neat it is to be able to take full control over the API on your Mac, because normally Apple's kind of like, no, you can't do that. But with Xcode, you absolutely can, and it's very easy. Special thanks to the AV crew. They're working really hard. It's a very thankless task that they have. The NOTACON, what? Bring you liquor? We'll work something out tonight, Adrian. And then NOTACON volunteers and staff and you. Great questions. Thanks for showing up early. Hopefully you weren't out partying too much. So I've got a little bit of time left. If you folks want to come over and see how the field sensor works and that sort of stuff, feel free to. We're going to get kicked out after a bit. I'll take the gear into the Q&A room, and then we can continue jamming on this. So thank you very much. Have a great time at the rest of the con.